This is my Dremel Digilab 3D45 printer, which I did a short review of when I got it out of the box at the beginning of the COVID lockdown. I bought it to add to my existing printers because I needed to make a lot of COVID face shields, and I must admit I've printed hundreds and hundreds and hundreds of them, so this printer has had a real hammering over the last 4 or 5 months, and I must say it's performed particularly well. I've also made 2 MPCNC machines, and the parts that you see on the build plate at the moment are for my latest MPCNC build. It's the spinner mount. So what I'm going to do to show you this printer in more detail is to print a small calibration cube. Whilst I'm doing that, I'll talk about the printer, and I'll try and show you the things about it that are very pleasing, that please me, and 1 or 2 niggles. There's very few niggles as it happens. It's a very good printer. So first of all, we will load the XYZ calibration cube into the software. So I've loaded up the Dremel Digilab 3D Slicer software, which comes with the printer on the thumb drive that they supply you with. It's actually a slightly adapted version of the open source Cura software, which is very good software. So the first thing we'll do is we drag our STL file that we want to print into the work area. There you are. There's my XYZ calibration cube that I want to print. And the other thing that we need to do is to set up the print values that we want to. First of all, choose the material that we're using. I'm using Dremel material, PLA. There's actually no need to do that if you are using Dremel's spools of filament, because the printer automatically senses what filament you're using and sets it up accordingly. Now for this cube, I'm not going to put any infill in at all, just to make it a little bit difficult for the printer. So I'm going to make it a completely hollow cube. So we'll set the infill density to 0. I'm going to set it to medium quality as well, so that it's not hyper slow, but I found that the medium quality is in actual fact quite a high quality, and there's no worries about doing that. The only other thing we really need to look out for is whether or not we want to generate support or not. I don't want to do that on this particular print. And how you want it to stick to the bed. I've got this at the moment set to just printing a skirt, so that before it starts printing the cube, it extrudes a little bit of filament, and you make sure the filament's flowing well before it actually starts the printing. So I click prepare, and the model will be sliced. Prepare. There you are, ready to save to removable drive, it says. So click on save to removable drive. There's a removable drive in the computer. It's actually sensed that, so it's automatically gone to that removable drive. There you are. There it is on the opposite screen. And so click eject, and we can take the movable drive out of the computer and take it to the printer. And now we're at the printer, The first thing I need to do is remove the previous print. Now the print bed is removable. Just have to tap these two and off it comes. So I will remove the parts that I've just printed using this convenient little tool that's supplied with the printer. They supply you with a nice little toolkit with everything you need. So I'll remove that, and then we'll change the spool. So I can show you how to load a spool, how easy it is to load a spool in this particular printer. And we'll print our XYZ cube in another color. Okay, we'll put the heated bed back. Now I've got a nice spool of white. I'm going to change the existing silver spool for a white spool, and so let's do that. All you need to do now is follow the instructions on the screen. So let's move in on the screen as close as we can. A little bit of focus there. Right, still referring to the previous build, except right now the options that we've got here, one of them is to change the filament. So we click on that, and it says we've got a choice between changing the filament and viewing or ejecting or something. So we want to change the filament. Click on that, and it says cut the filament. Right, we'll do that. The machine very conveniently brings the filament to the front of the machine to make it convenient for us to cut. Using the nice pair of filament cutters that they gave us in the kit, we cut the filament. There you go, right next to the next to where it enters the extruder. So I've cut the filament. What do we do next? It's now heating up the filament. Whilst it's heating up the filament, we may as well change the spools. So I'll do that. Remove the side, take the old spool out, find the new spool, now all you need to do is thread the new spool into the PTFE pipe at the bottom, push it through, hook the spool on to the spindle and stick the cover back on again. So we're all ready to go. I'm going to cut the end of the filament at a slight angle just to make it feed easier. I find that sometimes helps. Make the end nice and straight. Okay, what does it say now? It says, if we look, we'll see that the old filament is being fed out of the extruder, and the menu is asking us to feed the filament, which I will do. Stick it in there, and it's being sucked in already. So I'll click on next. What does it ask me to do? It says press done when a new color appears. This is going to be a bit difficult to see when the grey silver changes to white, but I think it's changed around about this position here. So we click done. Now what it's doing is detecting the RFID, the radio frequency radio RFID, I know, radio frequency ID, and it's detected it as PLA, which is good. Get rid of the filament that's been extruded, put it in your special container to take to recycling, and our new filament is ready. So you press accept. Now remember, we saved our model, our XYZ calibration cube, on the thumb drive. So I'll click back, and my next option is to build. Click build, and you've got the options of the internal memory and the thumb drive. Our model is on the thumb drive, so I'll click on that. There's our model, XYZ calibration cube. Click on that and click build, and off the printer will go. It's getting busy. There's our thumb drive, I plugged it in. While it's doing that, I'll talk about the various ways of getting the model to the printer. It has got an Ethernet connection, it's got a USB connection, and it's got Wi-Fi. So there's umpteen different ways of getting your model to the printer and monitoring the print as it goes. I'm not going to talk too much about that side of thing, because as far as I'm concerned, it's icing on the cake. I don't actually use it much, because this printer, I'm always around when the printer's printing, and I just stick the new model in on a thumb drive. But what the printer is doing at the moment is leveling the bed. It detects 6 different positions on the bed and maps out the irregularities on the bed. I'm not a great fan of this sort of thing. I prefer to do it manually, but it does the job very well. You do still need to calibrate the extruder according to the instructions, which I found a little bit confusing, mainly because I was used to other printers. But once the extruder's calibrated well, then you get perfect prints. It's taking a bit of time to level the bed, which can be annoying, but at the same time it is actually heating up the bed and the extruder, so we're not really wasting any time. The bed has to be extruded. Excuse me while I answer the phone. Right, while I was doing that telephone call, everything's heated up and it's extruded a little bit of filament, and it's warning me, caution, the door is open. So I'll close the door. 2 doors, one at the top, one at the side. Probably not a good idea to slam them, because it might be reflected in the print. I'm going to move up a little bit closer, open the top door in spite of what they say, and show you it printing. Nice and quiet. All you can hear really is the sound of the fan. And it shouldn't take too long to print that XYZ calibration cube. While it's doing that, I'll talk a little bit about the printer. I do have quite a few other printers, including a flash forge printer, and having taken the extruder assembly apart, I've discovered that it uses exactly the same extruder assembly as the flash forge, which is okay. After I printed maybe 10-12 reels of filament, I decided that I needed to change the extruder nozzle. The extruder nozzle has got a longer thread than the flash forge one, and I found it very difficult to find one on the internet. Usually extruders are quite cheap. You can get 3 or 4 of them for a £5. All I found was a micro Swiss nozzle, which is for I haven't had a lot of luck with those on other printers, so I didn't particularly want to buy one of those for 14 or 15 quid. So I got in touch with Dremel and said, hey, I can't find any nozzles for your printers. They said, don't worry, we'll send you one. And then a couple of days later in the post, I got 3 nozzles. Not only 3 nozzles, they had 3 complete hot end assemblies as well. As a hot end assembly costs around about £80 or £90. I was quite pleased with that. Above and beyond as far as Dremel are concerned. So if you buy one of these things, at least you can be sure of getting excellent support, which you don't necessarily get if you buy a cheap Chinese printer. They seem to be based in Holland, by the way, which is quite convenient for us. Anyway, they're very good with support. The other thing I need to talk about, I think, is the filament. You can buy purpose produced Dremel filament, which comes in ½ kg spools to fit the printer. Most spools of filament that you buy are 1 kg. The price of the ½ kg spool is probably more expensive than a standard 1 kilogram spool, non-branded. I was a little bit taken aback by that at the start, but I must admit it takes all the guesswork and all the anguish out of using filaments. And I usually find with a 1 kilogram spool, I use about half of it, then I change the spool and I never come back to the one I've used. So I've got hundreds and hundreds of half full 1 kilogram spools. Now I find with the Dremel it's so easy and quick to change the spool, and it fits right inside the printer and it's no hassle whatsoever. That's well worth the money you pay for it. Also, it's got RFID, so the printer knows exactly what sort of filament is in there, and you don't need to worry too much about variations in filament when you buy non-branded filament. Variations in filament quality, variations in content, variations in filament diameter, and so on and so forth. All the sorts of things that are there to trip you up. So the spools are expensive, but after probably quite a little bit of soul searching, I would say that they're worth it. So now I buy Dremel filament for this particular printer. Dremel produce PLA filament, which is good. They also produce something called ABS, which isn't really ABS, it's an enhanced version of PLA, so it's got the quality and strength of ABS filament, but with the ease of printing of PLA. It's an enclosed printer, so it's more or less constant temperature inside, so it's okay for printing ABS. If you've printed ABS, you probably know that it's quite a pain. It tends to come unstuck from the bed, it curls, it warps, and so on. Well, the Dremel version of the ABS doesn't suffer from any of those particular problems. They also produce PETG filament. I think when you buy the printer you get a roll of PLA and a roll of PETG. The PETG is strong. It prints easily, it's very easy to print. The only downside of it, as far as I'm concerned, is it's a little bit flexible, which is fine if you want flexible plastic. But I thought as PETG is strong, I'd print my CNC machines in PETG, which is a mistake. The CNC machine needs something that's really hard and non-flexible. So PLA is the answer for the CNC machine. The other sort of filament that they provide is nylon, which is very strong and it's good for printing parts like nuts and bolts and things that require a lot of strength. I've done some printing with the nylon. It works well. It's not pretty. It tends to be very stringy when you print it, but it serves well for the purpose. But you wouldn't really go around using nylon for everything that you print. Only use it for when nylon is required. What else can I say about the printer? Well, it's very reliable. As I say, I've printed maybe 10 or 12 spools of filament through this particular printer. I've done hundreds of PPE items, face masks and so on. And to be quite honest, I haven't had a single failed print on this. Which, in my opinion, is phenomenal. I've never had a printer that is just so reliable. Awesome. Anyway, we seem to be printing our little cube quite well. I'll see if I can zoom in on that. Focus. Focus. There we are, my XYZ cube. It's difficult for me to see whether it's focused or not. So we'll just wait now until that's finished and then we'll have a look at the cube. You say a cube is something simple to print, but this particular XYZ cube has got an X, a Y and a Z imprinted on each axis, and it is a recipe for introducing moire patterning, ringing and all the sorts of things that 3D printers suffer from. Also, it is exactly 20 millimeters in every direction, so you can also gauge the accuracy of your printer. So, I've never printed one of these on the Dremel before, so it should be interesting to see what the result is. I'll come back when it's finished printing. finished. Couple of things I need to mention. There is the printer's completely enclosed, and there's a filter so that all the air coming out of the printer, whatever toxic fumes it has or whatever, are filtered so you can have it in your office. It's also well lit inside with a neon strip, and there's a camera inside if you want to monitor your prints when you're not around. I don't tend to use those things, but if you do, it's very convenient. So let's have a detailed look at the XYZ cube. I can't take it off the plate just yet because the plate will still be warm and will still be sucked fast, so we'll just wait for everything to cool down. Okay, I've printed the cube, the x-axis, the y-axis and the z-axis. It's completely hollow, there's no infill, but it doesn't seem to have bothered the z-axis too much. I'll do a measurement. .14, 20.24, 20.10. So that is printed accurately to within 1/10 of a millimeter, which is probably, might even be the margin of error of my digital calipers. I'll take a detailed photograph of that so that you can examine it. There's one or two lines, nothing to be worried about. You get rid of those if you printed this in high quality. This isn't printed in high quality, it's printed in medium, and there's no evidence of ringing or moire patterning. So that's the first time I've printed a calibration cube on this printer, and it seems to have done it quite well. Just have a look at the photo. So while we're looking at the photo, I'll just finish off by saying I did pay full price for this printer. It's not a cheap printer. It wasn't sent to me by Dremel to review. I had to fork out my own money for it, so you can be sure that it's an honest review. You pay probably 3 or 4 times as much more for this printer as you would for an equivalent open source Chinese printer. But if you can't be bothered to be continually tweaking your printer, or you're not a printer geek and you don't really know anything about 3D printers, you just want to get one and print the stuff that you need to print, and this is the printer for you. And the price that you pay, which in the UK is about £1,200, in my opinion is very good value. There are cheaper Dremel printers, I haven't tried those, but if they're anything like as good as this one, then trust me, they'll be worth the money.